Now we'll go for the second question in permutations and combinations. The question goes on like this. 5 people are running in a race. The first one to finish wins a gold medal, the second wins a silver medal, and the third wins a bronze medal. How many different arrangements of medal winners in order from first to third are possible? Now, was a key word in the question that you can identify that there's a permutation combination? Yeah, that's right. This is how many, and that's how you identify whether it's a permutation or combination question. The first question that we saw in the first question was that you have to ask yourself is like, is it a case of same source or different source? Here they are like 5 people. Now I want you to answer my question. You can pause the video, but just try to answer the question. Is it a case of same source or different source? Now you may say, there are three things like gold medal, silver medal, and the bronze medal. But in fact, if you read the question carefully, how many different arrangements of medal winners is asking. Now, where do you pick up the medal winners? Is it from 5 people, or is it from this gold other medals? Indeed, it's from the 5 people. So it comes down to same source. When it comes down to same source, you have to ask one more question in the examination hall. Is it a case of does order matter or order does not matter? Now, how do you say that order matters or order does not matter? Like for example, I am one of the 5 people. I am running the race, and I run the race, and I get 3rd place, and they give me a gold medal. Will I accept it? Of course I would accept it and all that. But if I get the 1st place and they give me a bronze medal, will I accept it? Pakka I won't accept it. So indeed, the first person should get a gold, second person should get a silver, and the third person should get a bronze. So that's where the order matters and all that. So the first thing, when you come down to order matters, the first thing you're going to list it out is how many items are they to give. There are 3 items to give: 1 for gold, 1 for silver, 1 for bronze. Now tell me, who can get 1 gold medal? Any of the 5 people can get gold medal, right? So there are 5 ways in which you can give 1 gold medal to. And now coming to the silver medal, who can get now silver medal? Because one person already got a gold medal, he doesn't get it. So remaining 4, without any partiality, they can get the silver medal. And similarly, any of the remaining 3 can get the bronze medal. So you all have to do is just multiply, and there you go is the answer. So it's come to the third question. It's similar to the second question, but tell me whether it's same or not. Now here goes the question. The third question says 5 people are running a race. The first 3 to finish win gift certificates. How many different groups of people could win the gift certificates? Now, is it same as the second question that just now we have discussed? There's a small thing, there's a small word which makes it so different and all that. You may say that it may be the same certificates. No. It may be the same certificates or different certificates, it doesn't matter. But it's the key word that the groups. Like for example, if we have 5 people, A, B, C, D, E. If A, B, C, a group of A, B, C win the gift certificate, is a group of B, A, C the same group or a different group if they win the gift certificate? The same group, right? So because of that group, that's the order does not matter over here. Okay, so based on these 3 questions, we're going to sort out. Just you can go with you can go to the table and you can actually crack the question. According to the first question, the first thing you should ask yourself, is it the case of same source or is it case of different source or same source? The first thing you should ask yourself is it a case of different source or same source? Come to the first question that just now we have discussed. When it comes down to the same different source, the first thing is you just have to list the slots. Now how do you list the slots? Yeah, exactly, based on the number of sources. There are 3 sources, that's why we listed out 3 slots. So based on the number of sources. Now the second step is fill the slots. That's what I've done. Fill the slots and multiply. It's very simple. Fill the slots and multiply. Okay, now but how do you fill the slots and multiply? The first, basically there are like 12 choices for picking up 1 shirts and 10 choices for picking up 1 jeans. So based on number of choices for each slot. Now coming to the second and the third question, when it comes down to same source stuff, you should ask yourself, does order matter or order does not matter? The first thing, when order matters, the first step is the same. List the slots. Now how do you list the slots? You list the slots based on basically the number of items to give or number of items to get, okay, to receive and all that. Here basically there are like 3 items to give, but most of the time it's number of items to select and all that. So you can actually say based on the number of items selected. The second step, fill the slots and multiply. Now how do you fill the slots and multiply? Here any of the 5 people can get gold, remaining 4 people can get the silver. So it's based on number of choices left for each slot. Now similarly, the third thing, in the third case, when order does not matter, all you have to do is the same thing, is to list the slots. That's again the same step based on the number of items selected. It's the first step. The second step, fill the slots. Now again it's the same thing based on the number of choices left for each slot as in the previous question, but there's the third step. The third step is divide by the factorial of the number of slots. It's very simple to, what does this mean is, what the step mean is, it's nothing but divide by the slot number. Okay, now here this order matters is nothing but permutation. The key words that you have to see in permutation is nothing but, it's like order. That's how you recognize the question whether it's like permutation or combination and all that. This actually is the NPR formula and this is nothing but the NCR formula. But it's more logical, and this especially for exams such as like GMAT, GRE and SAT students and all. The second is arrangements. That's how this is like a trigger. It's like when the question pops up on the computer screen, you identify a question based on these keywords. Third, schedules. Order does not matter, and even positions. You can go ahead with positions. Like for example, first place, second place, third place and all that. Or the first person wins the yellow ribbon, second person wins the blue ribbon, third. You can identify like that. Order does not matter. It's nothing but combination. This is your NCR formula. the ways you use, like the way you can recognize this combination is groups, committees, selecting. Be careful, sometimes it says selecting and then arranging also, but it's like selecting, choosing. So these are the ways how you can identify. So coming back to the third question, the first step, what does it say? Because we come down to, it's a group question, so how many different groups of people could win the gift certificates? The first step is list the slots, because how many how do you list the slots and all that? The same thing, based on the number of items is selected and all that. How many items is selecting? There are 3 gift certificates to give, right? So I'm listing out 3 slots, 1 for each certificate and all that. Now, who can get the first certificate? The second step says fill the slots based on the number of choices left for each slot. The first certificate, any of the 5 people can get. Second certificate, any of the remaining 3. The last step says divide by the factorial of the number of slots. Now it says divide by the factorial number. There are 3 slots, so you can divide by 3 factorial. Or if you're getting if you're very confused with, or you're getting scared with what is factorial and all that, you just have to remember this one. Divide by the slot number. That's all. The first slot put 1, second slot put 2, third slot put 3. And all you have to do is multiply. 3 gets cancelled, 2 goes 2 times, 5 2s are 10. And there you go. That's your answer. And there are many things that you there are in permutations and combinations. This is one of the method which I teach for the students, and if you want to learn more about the permutation combinations, you can come and join me. Thank you.